Hello, and welcome to this Hot Tech Tips webinar for using IBM SPSS statistics. This webinar is the second webinar in a series of webinars. My name is Astrid Cook, and I'm an analyst here at version 1. So here's an overview of the topics that we wanted to cover with you today. So first of all, we'll start with custom tables. So we wanted to show you how to visually build the table that you need without format restrictions and unnecessary items. Then we'll demonstrate linear regression. Now, we use linear regression when we want to predict a numeric outcome, and I'll show you two methods. One is a simple linear regression, and then we'll add more predictors, but we'll use automatic linear modeling. Then I'll show you how to set up and run a binary logistic regression, and we use logistic regression when we want to predict a categorical outcome. So we'll run the regression, and then I'll show you how to test it on a holdout sample. Finally, I want to introduce you to survival analysis, and this is where we predict time to an event, when in some cases the event may not have yet occurred. And here I just wanted to show you the options that you have in SPSS, some of the extensions, and what's new in version 29. Now we'll look at custom tables first, and we quite often get the question, how can I build customized tables that show what I want and only what I want? And that's where custom tables is really powerful. So I will show you how to do that. So I'm in statistics, and I have survey data here. And this data is a mix of demographic information as well as attitudinal information. So I have some questions down here. Respondents were asked about their confidence in banks and financial institutions, their confidence in major companies, confidence in education, the press, medicine, and television. They were also asked where they're getting their news from. So do they get it, for example, from television, from the radio, from the internet? There's quite a lot of information in this file. Now, some of this information I do want to show and summarize in table format. So typically we would start on the Analyze menu, go to Descriptive Statistics, and select Frequencies. So I may just simply want to run a table to look at categories of marital status. So you can see I have my frequency table. I have my counts. I have the percent, the valid percent, and the cumulative percent. So that's a lot of information in one table. And I may not want all of that information. Maybe all I want is just the counts. Also, if I go back into frequencies, perhaps I want to look at marital status with TV hours. Now I have two tables. Again, I may not want the valid percent and the cumulative percent and the percent. Perhaps I just want counts. Also, if I look at hours per day watching TV, again, I don't really get a lot of information out of this table. And I'd actually like to have both of these variables in one table. So let me show you how to do that in custom tables. I'll go on the Analyze menu, come down to Tables, and pick up Custom Tables. So I'll start by picking up TV hours, and I'll drag it into the rows. Now, TV hours in this data set has been defined as a scale variable. When I drag it onto the rows, it recognizes that it's a scale variable, and it gives me the mean or the average. I'll take marital status, and I'll drag it into the columns. And now you can see I'll have average TV hours per day in every category of marital status. I'll click on hours per day watching TV. I want some summary statistics. And here what I'm doing is just doing a little bit of editing. I want my mean to have 2 decimals. I'll apply to selection, click on close. And now in the preview, you can see how the table will look. I'll click OK. And of course, you can see I now have a very compact table. I could either have my information across 2 tables or in one table. And I notice right away that our widowed watched the most. You can see their value here. But again, I can compare across all the categories of marital status. And if I would like, I can go back in, click on Test Statistics, and compare column means. And of course, here it will adjust p-values for multiple comparisons. I'll click OK. And now I've got two very nice looking compact tables. I can compare the averages across categories of marital status. And below, I have a comparison of column means. So I can look and see that our widowed, who are watching the most TV, they watch significantly more TV than our married, category A, our divorced, category C, and our never married, category E. Now, if you're looking at this output and you're thinking, actually, I'd like to change the look of those tables, that's straightforward to do. I'll go on the Edit menu and I'll come down to Options. And I'll click on the Pivot Tables tab. And to the left, we have a Table Look section. If I click down, you can see I've got a blue table look. I've got a blue-yellow table look. I want the classic, which is gray and white. I'll click OK. I'll go back to the dialog recall box. I'll pick up custom tables. The table that I've just run is sitting in there, and I'll click OK. Now I have changed the look of the table. There's one more thing I'd like to do is I'll click on the Table 1 title, and I will insert an image. So I've inserted a logo. And now I'm ready to export this output. So I'll highlight these three pieces of output. I'll right click and I'll export. And this brings up the export output dialog box. You can see we've got a type section. It's actually a drop down menu. So I might want to export this out to Word, or perhaps I want to send it out to HTML. I'll send it out to PDF. And I'll browse for the location that I want to send it to. I'll give it a file name. I'll save it. And this will open the containing folder. And now you can see we have our output in a PDF file. So that's actually very handy. I can send this to anyone. They don't have to have statistics installed. You don't need to send them output from SPSS. You can simply export it out as a PDF file. And of course, I've got my tables and I've got the table look that I want. You can see how easy it was to build these tables. Let me go back into custom tables. Let me click on reset. I want to reset all my tabs. And let me talk a little bit about working in custom tables. So to the left, we have the list of our variables. So I can see all the variables in the data file. And if I right click on any variable, I can show the short variable names or the longer labels. So here I can see the label is marital status. The short variable name is marital. I can right click and I can sort the variables alphabetically by file order or by measurement level. Again, it's up to you. If you've got a big file, maybe you want to sort it alphabetically. For me, I'll keep it by file order. And then if I select variable information, this will show me the short name, it will show me the longer label, and it will show me the categories of marital status. Again, I can click on, for example, work status, and I can see the categories shown below. Also, you can see how the data has been typed in the data file. So for example, three bubble icon means this is nominal, ruler means it's scale, and the bar chart means it's been typed as ordinal. Now, to get started, I can simply drag and drop. So I can drag a variable onto the rows. I can drag a variable onto the columns. I can drag things back out. And of course, as I'm dragging, that creates a table, and I can see it as a preview. Now let's talk about types of tables. I can build a simple table. So I just want to look at marital status. I just want to see the counts. I would like to see the total count, missing values. So I'll specify that here and here. And then I want to do some sorting. So I'll sort by the count, and I'd like to sort it by descending order. I'll click apply and I'll click OK. Very simple table. All I wanted was the count and it's sorted. Of course, I can go back in. I'll click on marital status. I might also want to add column percent. I'll click apply and close. You can see in the preview what it will look like. I'll click OK. So again, a very simple table. We don't need a table with a bunch of columns in it. We just wanted the count and we just wanted the column percentage. So let me go back into custom tables. So again, simple table here. We can also stack. So I could drop work status below marital status. You see how it's highlighted the red box? Let me click OK. Now I have one variable stacked on top of another variable. So that could be very handy. I can also nest. So perhaps I'd like to nest a variable within marital status. So you see, I drag that variable within marital status. See how it's highlighted to the right of the categories of marital status? And I'll click OK. Now we can see we've got whether or not they get their news from newspapers nested within every category of marital status. Of course, you can also build a crosstab table. So I could cross marital status with, for example, self-reported happiness. I'll drag that onto the columns. And then I'll ask for some summary statistics. I'll click apply and close. And I'll click OK. And now I have a crosstab table. I've got the count, the row percent. Of course, one of the great things about custom tables is for the summary statistics, I can actually change the position. So I moved the summary statistics from the columns to the rows. This means the count will appear above the row percent. And then I can see, for example, here, 43.5% of my married respondents report that they're very happy. Another 51.2% report that they're pretty happy. And another 5.3% report that they're not too happy. So again, a crosstab table. Of course, one of the great things too is that if I want, I can ask for a chi-square test. So this will test the association between marital status and happiness. I can see that the test is significant. It's less than 0.05. So it is, these two variables are significantly associated. And if I want, I can stack a variable below. So I've got marital status stacked on top of labor force status. Now, right away, you'll notice something. In the marital status section, we've got count, row percent. Down below, we've just got count. But I'll click on marital status and I'll click on summary statistics and let me move this window. What I will do is take all of the settings from marital status and apply it to labor force status. How do I do that? I'll click apply to all and I'll click on close. Now you can see we've got marital status stacked on top of labor force status. And now we have two Pearson chi-square tests. Of course, I can go back in on my test statistics. I can adjust the significance level. So I'll drop it to 0.01. And then I want to do one more thing. On the Options tab, I'll select Table Style. For my Pearson chi-square test table, for my significance value, if it's less than or equal to 0.01, because remember, I changed that significance value, I'll click Continue. It's highlighted yellow. Now, of course, I could change that if I wanted to, but I'll leave it highlighted as yellow. I'll click Continue and I'll click OK. Now again, you can see I've got a stacked table. So marital status stacked on top of labor force status, crossed with general happiness. And I have two Pearson chi-square tests. Remember, I was able to adjust the significance level and also highlight significant tests. Of course, if I'm happy with this, again, I'll click on Table 1 title. I'll go ahead and insert, in this case, I'd like to insert an image. And of course, what I can do is just highlight my output, right click, export. Again, I want to send it to a PDF. I'll browse to the location, have my file name, and I'll click OK. It will tell me that it's exporting. And now I have my output. So you can see how easy it was to quickly build that table. And I have my output in PDF format so I can share it with anyone. So let's go back into custom tables. Let me click on reset, and I want to reset all of my tabs. Now, if I come down, I've got these confidence questions: confidence in finance, confidence in business, confidence in education. Now, I can use these in custom tables, but if I go back on descriptive statistics and frequencies, let me reset and clear everything out. Let's look at this first as frequency tables. So let me pick up these variables and let me run the tables. So you can see, first of all, we now have 6 tables. And again, each table has frequency counts, percent, valid percent, and cumulative percent. And when you look at your output this way, it would be hard to compare each of these questions. If I go back into custom tables and I pick these up, I could drag them onto the rows. So a little bit easier in that they're all in the same table. All I have right now is counts. But there's something that I can do in custom tables that is absolutely fantastic when you have these blocks of questions. Remember, we've got 6 questions. They all have the same response categories. So if I go back into custom tables and I come down to category position and I put row labels in the columns and I click OK, now you can see we've got questions in the rows, response categories in the columns, and now we can start comparing. So what I will do next is I'll click on the first question, summary statistics. I'd like a row percent. I'll do a little bit of editing on the label. Again, let me move this window just slightly. If I say apply to selection, you can see it's only applied to that first confidence question. If I say apply to all, it gets applied to all of the questions. And I'll get rid of the count and I will apply to all. Click on close. We can preview the table. I'll click OK. Now I've got a very useful table. One of the things that I can see is in the hardly any column, again, they were asked, how much confidence do you have in banks and financial institutions? 16.4% said they have hardly any confidence. If we look at confidence in the press, confidence in television, you can see it jumps up considerably. So this is confidence in the media. And one of the things that I can do that is really useful is I can create a new column in this table. So I'll go back into the table that I've just run. So I'm back here on the dialog recall button. I'll pick up custom tables. My table is still there. I will click on the first confidence question, right click, and then I want to select all row variables. And I will click on categories and totals. And I'd like to add a category called difference. And now I'm taking a difference between column 1 and column 3. And of course, I can sort and apply. So difference is to the right, the last column, and I'll click OK. Now you notice that we have negative values here, confidence in the press and confidence in television. And again, this is showing me that my respondents have hardly any confidence. So it's a much higher value here than it is here. Of course, I can go back in on options. I'll click on table style for my custom table. If it's less than 0, I will highlight it, click continue. And now you can see I've highlighted these cells. Again, you saw that I started with 6 tables and now I'm down to a very compact table. I'm able to compare directly the percentage response in each category. I can pull out the categories where, again, respondents have hardly any confidence here and here. Again, I took a difference between a great deal and hardly any, and I highlighted here the negative values. So I can have a table that looks like this, or I can have 6 tables. So you can see this is a much more compact, more useful presentation of the information. So again, custom tables, very easy to use. Again, it's drag and drop. I can stack tables. I can nest. So again, I'll bring across the news. But again, you can see how easy it is to drag and drop and build. Again, you can ask for test statistics here. And of course, on the options, you can use the table style to highlight. So again, custom tables, very powerful, very useful. Now, the next thing we wanted to talk about was linear regression. So with linear regression, we predict a numeric outcome. And we want to be able to predict what we don't know or would like to find out about or influence using information that is known or can be controlled. Now, with linear regression, we've got some key assumptions. So first of all, there must be a linear relationship between the independent variables and the dependent variable. You want to ensure that only relevant information is being used. You want to ensure that there's constant variance in residuals or errors, and that the variables used to predict are not significantly related to each other. This is called multicollinearity. Now you can see that multicollinearity is highlighted in red. I've highlighted it red because obviously it's a huge problem. But if we look at these assumptions, it's important to check these. Of course, we offer a complete 2-day regression course, and we walk you through all of these assumptions and the checks. And in particular, we do a whole section, a whole module on multicollinearity. What I want to do today is just introduce you to linear regression, show you a simple linear regression, and then show you automated linear modeling. So here's some output. Again, I'll set this up in the dialog box and run it, and we can see it again. But just to show you the output, first of all, we have the model summary table. So I've highlighted the R-square value here. And this is the proportion of variance in the dependent variable explained by the independent variables. Here, it's the proportion of variance in current salary explained by the model or explained by beginning salary. You can see it lists the predictors here. So we're just going to use beginning salary to predict your current salary to start with. And again, we can see the R square here. We have the ANOVA table. This tests if there is a significant relationship between independent variables and the dependent variable. We can see there is a significant relationship. And then in the coefficients table, again, we can see the beginning salary is a significant predictor of your current salary. We also have the constant and the slope. And we can use this information combined with someone's beginning salary to make a prediction about their current salary. Now, automatic linear modeling, again, I'll show you where this is and I'll show you how to set this up. This actually transforms your data prior to running the model. It can also select predictors and it provides a more visual output. Now, if you look to the left, you can see we have a model summary. When you run this, you will get a box that will show the model summary. You'll just need to double click to open this up so you can access all of the other output. Here's some of the other output that you can get. So, for example, it will do automatic data preparation. So, for example, your beginning salary, you can see it trimmed outliers. It will give you a predictor importance chart. So you can see beginning salary, again, the most important predictor, followed by employment category, previous experience, and months since hire. We also have our coefficients down here, and we can see ones that are positive, which is blue, and negative, which is orange. And again, we also have an option to show this as the coefficient display here, or if you would like, in a table format. So let me show you linear regression. So I'm back in statistics, and I have data on employees of a bank. And here I have their beginning salary and I have their current salary. I also have other information about them, for example, their education, previous experience, job time. And to get started, I want to go on the Analyze menu, come down to Regression, and I'll open up the Linear Regression dialog box. You can see there's an area to place a dependent variable. There's an area to place independent variables. We've got a method selection, and we have other buttons to the side. Now, to get going, to get started, I want to start with a simple linear regression, and then I'll just run it so we can look at the output. So we want to predict your current salary using your beginning salary, and I'll just click OK. And again, you can see we've got the model summary table, so I will just double click, and I'll open this up. Now, if you need to highlight anything, for example, if I want to highlight the R square, I'll just click in the cell and I'll highlight it. And also, if you need to, you can click on R square, right click and ask, what's this? And it says goodness of fit measure. So it's great because you can click again on statistics and ask, what's this? But again, we can see the overall fit here, the R square, I've highlighted it. And we can see that your beginning salary explains about 78% of your current salary. Again, we can see there is a significant association between the independent variable and the dependent variable. And then if we come down, we can see that your beginning salary is a significant predictor of your current salary. Now, of course, in this example, I've just put in one variable, that's your beginning salary. I'll go back on the Analyze menu and I'll come down to Regression and I will bring up Automatic Linear Modeling. Now, to get started, click on Use Custom Field Assignments. Your current salary will be the target. I'll use beginning salary. I'll move more variables into the model. So I'll pick the variables that I'd like to bring into the model. I'll click on Build Options and I'll select Basics. So you can see there's objectives, the basics, model selection. But if I click on Basics, it will automatically prepare data. So it does automatic data preparation steps, and they include, and then it lists them. So for example, it will do outlier and missing value handling or supervised merging. Let me click on Run. And again, you can see you get this model summary box. Again, I need to double click to open it. And then down the left-hand side, you can see the output. So we'll start at the top. The model is 80% accurate. Here, automatic data preparation, it shows me how it's transformed the data. So again, beginning salary, it trimmed the outliers. It will show me predictor importance. So again, beginning salary at the top, then employment category, previous experience, months since hire. And then if I come down, the coefficients. So you can see the blue are positive, orange is negative. If I take my cursor and I hover it over, for example, beginning salary, I can see the coefficient, the significance, and the importance. Again, I can look at job time, previous experience. Also, just so you're aware, down here, the style option, diagram or table. Again, you can have it in a table format if you want, but we can see again, beginning salary, significant predictor, job time, for example, is a significant predictor. But again, you can have it as a diagram or you can have it as a table. So that's automatic linear modeling. Again, on the Analyze menu, we can go to regression. We have linear, and then we have automatic linear modeling. So now we'll have a look at logistic regression. So we use logistic regression to predict a categorical outcome. I will show you binary logistic regression. And what I want to understand is customers who take up a news channel subscription. So this dependent variable has two categories. They either did or did not take up the news channel subscription. I have information about my customers, and I want to use this information to build a model to predict the take up. So I'll show you how to do this in SPSS. And then I also wanted to show you how to test your predictive model by blind testing on a random sample of cases. So if I want to predict whether or not my customers take up a news channel subscription, why not use linear regression? Well, conceptually, if we're trying to predict two groups, they either did or did not take up the subscription, then the predictions can be considered as probabilities. If we try and fit a line to this data, then we may get predicted values less than 0 or greater than 1. Technically, we'll have problems with homogeneity of variance of residuals around the line of best fit. The cases won't be evenly distributed around the line. Rather, they will cluster around probabilities of 0 and 1. So we have the logistic regression equation, and this is based on linear regression transformed into a probability function. And it estimates the probability of falling into group 0, no, or 1, yes. If the probability is less than 0.5, the case is assigned to the lower category. If the probability is greater or equal to 0.5, case is assigned to the upper category. Now, here's some output from logistic regression. Again, I'll run this in SPSS and I'll walk you through this. But first of all, as with linear regression, we have the model summary table. And here you can see I've highlighted the fit of the model. You can see that the variables that I've included explain about 20% of the variance in news channel take-up. Also, I double-clicked to open up the table and I asked, what's this? So always remember that you can ask what's this, so you can click on a statistic and it will give you information about that statistic. So I'll show you how to do that. Below we have the classification table. And if you notice, we have observed crossed with predicted. So overall, the model is 66.2% correct. You can see that here. If we look at those that did take up the news channel offering, you see the yes category here. You see that we correctly predicted 264 and we mispredicted 164. So the accuracy rate in the yes category is about 62%. Below this, we have the variables in the equation table. And you can see we included education, gender, and age, and they are all significant predictors of news channel take-up. Now, to test a holdout sample, how to do this? Well, first of all, I'll randomly select cases. So what I'm doing is selecting out a training data set. So I'll select 70%. This will create a filter variable in the data set, and then I will turn off the filter. And then I will use the filter variable in logistic regression. So I'll show you how to do this. So why do we want to test a holdout sample? Well, we do this because we want to increase the certainty we have in our model. If you create a model on your whole data set, then you'll create a more optimistic view of how well the model will perform when applied to new data. So it isn't just that we want to build a model on the existing data that we have. We want to actually take new data and apply the model to it so we can make predictions. And taking a holdout sample, testing it on a holdout sample, gives us greater confidence in the model. In other words, we want to be sure our model performs well on a holdout data set. So now I will demo logistic regression. So I'm in statistics, and you can see I have my data file. I have a news channel here. So this is whether or not customers took up the news channel subscription. So you can see it says accept new service offering. And you can see that 1 means that yes, they did. 0 means no. So I'll go on the Analyze menu. I'll come down to Regression, and I will pick up Binary Logistic Regression. And again, I'm using Binary Logistic Regression because my dependent variable, News Channel, has 2 categories. And I will move this into the dependent variable box. Below that, you can see we have the covariates box. So I'll pick up the variables that I'd like to bring across. And also, if I had categorical predictors, I would include them here. Click on the categorical button, bring them across, and this will dummy code categorical variables for me. So that's quite useful. With linear regression, if we had categorical variables that we wanted to use as predictors, we would need to dummy code them. Here on the logistic regression box, you can see we've got the categorical option, and this will code our categorical covariates. Now to get started, I'll just click OK. And again, you can see down here, I have my model summary here. And then again, the classification table. If we look at the overall percentage correct, we can see it's 66.7%. If we look at it within the take-up category, again, remember, this is observed, crossed with predicted. 544 cases were correctly predicted. 316 cases were mispredicted. This gives me an accuracy of about 63%. And then if I come down, I can see that education, gender, and age, these are significant predictors. So again, if I want, I'll go back into the model summary table. I can highlight the model fit. I can open up the classification table. I can highlight the accuracy within the yes category. And of course, I can come down and I can highlight the significance values for education, gender, and age. These are significant predictors of take up. Also, don't forget, if I open up the model summary table, you can right-click on any statistic and ask, what's this? So that's an introduction to binary logistic regression. Now, let's talk about testing on a holdout sample. To get started, I'll go on the data menu and I'll select cases. And I want to take a random sample of cases. So I will sample 70%. I'll click continue. And I'll click OK. This creates a filter variable. And if you look down to the right, I have a message that tells me the filter is on. So I'll go back on the data menu, go back to select cases, and I will select all cases. And I'll click OK. Now the filter message that was here is gone, so the filter is turned off. And if I look at my filter variable, you can see it tells me approximately 70% of the cases. So if it's got a value of 1, this was selected. A value of 0, this was not selected. Now I'll go back into logistic regression, and I'll actually use this filter variable as a selection variable. I'll set the value to 1, and I'll click OK. And what this does is it gives me a classification table. And you can see we've got selected cases here, unselected cases here. The selected cases is 70% of our data. So we did random selection. Unselected cases is what was not selected, so the 30%. This is our training, our testing. This is our holdout sample. And what we're looking for is to ensure that the model performs the same in the training and the testing. If we look overall, you can see 66.8% correct here, 66.5% correct in the holdout sample. If we look at yes, you can see 63.2% correct here and 61%, really 62% correct in the holdout sample. So again, not a huge difference. So we can be confident that our model performed well in both the training and the testing or the holdout sample. So again, to get to logistic regression, we go to the regression menu. We started with binary logistic because our dependent variable had 2 categories. We selected our predictors, we ran it. Here you can see we used the filter variable that we created, so we could test it on a holdout sample. Now we want to talk about survival analysis. So we use survival analysis to predict time to an event when in some cases this event may have not yet occurred. So we're understanding not just if an event will occur, but also when. Now again, here we just wanted to show you what's available in SPSS. So again, with survival analysis, we examine the length of time to a critical event, possibly as a function of predictor variables. So here are some examples. So here's one: renters of commercial space are interested in predicting the length of time a tenant will remain in the space and how long a space will stay empty. Now, time has interval scale properties. We might think about using regression or ANOVA, but there's a problem with these techniques because survival data has censored values in it. So these are observations for which the final outcome is not known, but we do have some information. So here's an example. So the main outcome measure, again, in survival analysis, is the length of time to a critical event. So in the example here, we want to know, does a new treatment have any therapeutic benefit in extending life? So we ran survival analysis to compare overall survival rates between 2 groups to determine whether the experimental treatment is an improvement over the traditional therapy. So here, if you look to the right in my data set, I have the group, I have control, and I have treatment. I have survival time, and then I have the status. Is it censored or did the patient die? And again, we have summaries in our output, so mean and median survival times. So the mean survival time, it's not simply the sample mean value, but it's estimated using the cumulative survival plot that adjusts for censored data. So this is why we use survival analysis, because we have this censored data. Here you can see if we're looking at mean survival time, again, we've got control here and treatment here. Now, as for options in SPSS, you can see we have the legacy methods here, but we also have extensions. So here are the extensions. And then new in version 29, we have parametric accelerated failure time models. So in terms of downloading extensions, you would need to go on the extensions menu, go to Extension Hub, and then you can search for the desired extension. Here we've got competing risk survival regression. If you tick Get Extension, it will install it into SPSS. If you're working in version 29, you can go to the What's New in the Welcome dialog. You can go on the File menu, select Welcome Dialog, and it will bring up information on what's new. And again, it will give you a little bit of information about the parametric survival models. So with survival analysis, again, we predict time to an event when in some cases this event may not have yet occurred. We can ask, what is the average time to failure? What is the probability at a particular time that a failure will occur? How do survival rates compare between different groups? And what impact do other factors have on survival rates? So that's everything we wanted to cover with you today. So we talked about custom tables. We showed you how to visually build the table that you need without format restrictions and unnecessary items. We did a quick review of linear regression. Again, just an introduction to simple regression, and then we showed you automatic linear modeling. We gave you an introduction to logistic regression. We showed you binary logistic regression, and then we showed you how to test the model on a holdout sample. And of course, we showed you what was available in SPSS for survival analysis. Now, if you need a complete overview, we have many courses that we can assist you with. So again, for example, we've got a regression course, we've got an analysis of variance course, we've got structural equation modeling. We can also design a customized course for you. Here's an example. We've got advanced statistical analysis, and you can see all of the options that we have. We can cover all of these topics over 2 days, or we can cover some of these topics. So again, please feel free to contact version 1, contact the training team, and we can assist you. So that's everything we wanted to cover today. For more hot tech tips, you can go to the webinar section of the site within the Learning Hub. Of course, you can contact us at spssadmin@version1.com. You can phone us. And of course, you can check out our website at www.spssanalyticspartner.com. So thanks for watching, and bye for now.